Have you ever wondered, how many rules does it actually take to run the entire universe? It sounds like a simple question, right? But it cuts to the absolute heart of reality itself. And, the answer might be changing as we speak.
You see, for the longest time, physicists thought they had a pretty solid answer. But now, a new debate is challenging everything we thought we knew about the bedrock of physics. Is it some complex system with multiple pillars holding it up? Or is it elegantly simple, resting on just one?
So let's start with the classic view. For decades, the established rulebook for the universe, the one everybody agreed on, was built on three core independent pillars. This was the foundation that giants like Einstein and Planck built their world-changing theories on.
And when you look at it, that foundation was, well, pretty straightforward. To describe basically anything in the cosmos, you just needed to measure its length, its duration in time, and its mass. The meter, the second, the kilogram. Three distinct concepts that you just couldn't derive from each other. They were the basics.
And here's the really cool part. These base units aren't just some random measurements we made up. No, they are deeply, deeply connected to the universe's most famous numbers. The speed of light, which ties space and time together, Planck's constant, which is the rulebook for the quantum world, and the gravitational constant, which dictates the force of gravity itself. So, yeah, for a very long time, the answer to our big question was simply three. Three fundamental, unshakable constants holding up all of reality. End of story. Or so we thought. But you know how it is in physics, right? Nothing is ever truly settled. A radical new idea has emerged, and it's proposing a dramatic simplification of this whole cosmic rulebook. And it all starts by asking a really simple question. I mean, really, what if we've been overcomplicating things this whole time? What if reality, at its most fundamental level, doesn't need three big pillars to stand on? What if it only needs one? And that is the absolute core of this new theory. Forget three. The new answer being thrown around is just one. A single, fundamental unit from which everything else, mass, distance, the whole shebang, can be derived. So what is this one special unit? The one constant to rule them all? Well, according to a new paper that's got the physics community buzzing, it's time, the humble second. The whole theory is that if you have a perfect clock, you literally have everything you need to describe the entire universe. Okay, so how on earth does that even work? How do you measure distance with just a clock? Well, the trick, as our source material calls it, really hinges on two big assumptions. First, that you have a perfectly stable clock, something like a cesium atom, and second, that the speed of light is absolutely, totally constant. If you know how long it takes light to travel from point A to point B, and you know that constant speed, you can calculate the distance. Boom, length just becomes a property of time. It's an elegant, beautiful idea, isn't it? So simple. But, of course, as soon as it was proposed, a crack started to appear in the theory, a big one. An expert counterargument emerged that, get this, agrees with the number one, but completely, totally disagrees on what that one constant actually is. And this critique lands a powerful blow right at the foundation of the whole idea. See, as this quote explains, a clock isn't some perfect, abstract thing. It's a physical object that changes, and just assuming it's perfectly stable, well, that might be a huge mistake. The critique really breaks down into a few key problems. First off, are cesium atoms truly stable? We don't have a full theory for the particles that make them up. Second, the idea just kind of ignores the super weird physics at the tiniest Planck scale, a realm where our current rules just fall apart. And finally, there's this philosophical problem. Can you really define length using time without already having a concept of length to begin with? It feels a little circular, you know? And this really gets to the absolute heart of the disagreement. The new paper says time is the bedrock, the foundation of everything. But the critic says, no. Time isn't the bedrock. Time is just the yardstick we use to measure changes in the bedrock. It's a really profound difference in perspective. So, if time isn't the one true constant, then what is? This is where it gets really interesting, because the critic doesn't just tear down the other theory. They propose a fascinating alternative. And this question is the pivot for the whole argument. The author asks it perfectly. If time just measures change, the truly fundamental question is, what is the what that's actually changing? And here is the mind-bending answer they propose. The one true constant isn't time,
but a property of space-time itself. Think of it like the stiffness or the elastic resistance of the very fabric the universe is made of. It's this property, the author argues, that dictates how everything else has to behave.
And this is what's so fascinating about this whole debate. Both sides actually agree on the beautiful idea of a single constant. They agree the universe is fundamentally simple. They just fiercely disagree on what that simple foundation actually is.
So let's just recap this whole intellectual battlefield. We started with the classic view, right? 3 constants. Then came the big one constant challenge, championing time, and now we have the counterproposal. Still just one constant, but one based on the very fabric of space-time. So what's the big takeaway here? What should you walk away with? For me, the most exciting thing is that the very foundation of reality is not a settled issue. It's a live, active debate happening right now. The push is towards simplicity, but the nature of that simplicity is still a profound mystery. Which leaves us with this final, massive thought. As we try to read the universe's ultimate rulebook, what's the most fundamental letter in its alphabet? Is it the tick of a clock? The marking on a ruler? Or is it something far deeper, far more intrinsic, like the tension in the very fabric of existence? The answer is still out there.